How many of you guys are all rugby fans? All right, we're going to do something funny for the States, okay? I'm going to record all you guys. I promise not to post it on YouTube more than 100,000 times. We're going to say rugby rules, football sucks. Ready? Set. And when I say go, we will record. Go. Rugby rules. Whoa. All right, good. Now I got some enemies. That's not good. Okay, let's go and get started. So thank you guys for attending my session. My name is Tony Sanchez. I'm with Citrix Systems. Everyone's got a full stomach. No one's going to pass out. If you are, there's beds out there if you feel like falling asleep. But hopefully I won't put you to sleep. We've got a lot of good data we're going to cover in under 60 minutes. I also want to say we got a great video team back there, so everything should be sweet as they say. So we should have no video hookups or hiccups like we did yesterday. So we had some yesterday, but should be all good today. What do I do at Citrix? I work on our worldwide alliances team. I focus on scalability on one particular hypervisor, Hyper-V. Do I know XenServer? Kinda. Do I know vSphere? Kinda. Do I know Hyper-V 2012 pretty well? Yeah. Do I know the optimizations, the things that make it work with the XenDesktop really well? Absolutely. So we're going to cover that in depth. A lot of good stuff you're going to learn about. The session agenda we're going to cover is pretty simple. We're going to go over version 7. No marketing slides. Going to get a hoorah? None of those. Pure technical stuff. We're also going to focus specifically on provisioning services version 7. That's basically the secret sauce and has been the main architecture component of XenDesktop and XenApp for a few years now. If you're curious about MCS, the cloning technology, I won't really go into that, but I'm happy to talk to you afterwards and go over different architectures. We'll also go over a couple demos, not too many, and I have a ton of optimizations and tricks that you can use in your testing and hopefully later on if it works in production for scaling. And then we'll go over one future demo that I have at the very end, which is going to be pretty cool because it's something that will help you go from 0 to 100 in under 15 minutes for a complete XenDesktop setup. So, quick quote from someone. Does anybody know who this guy is? Yeah, co-founder of Citrix. Great, brilliant man. So it's interesting. I think about his quote, where we are then versus where we are now. And it's really true. This guy and a couple other people really helped pave the way for what you see today and things that have changed in over 20 years. So Nakabuchi had a great vision, great idea, and lucky for us, it worked out very well. So let's go over the architecture that we have here. In version 7, there's a lot of different changes, but we're not going to go over them because we're really focusing on just scalability. That's what this whole session is going to be about. Not really so much design, but what are the pure performance numbers I can look at and what can I expect when I'm looking to use this hardware, this software, and this storage together in an infrastructure. Throughout all this presentation, some of the main things I'm going to focus on are going to be Windows 8 and Windows 7. We have a ton of stuff for Server 2012 RDS, Server 2000 R2 RDS, if that's what you're looking to deploy. But I won't cover that in this presentation because that could take 3.5 hours. That's a really, really long set of architecture decisions that we can look at and has different scalability number results. So basically what we're going to focus on here is going to be PVS, what you see in the bottom corner here. It's got a nice little pretty orange square. That's the main function of XenDesktop that we're going to focus on for delivering that common single image. So with that, let's get into what's new. First, of course, if you're curious what we support and you're not at the latest version of 7, we do support Hyper-V 2012 out the gate. We do support SCVMM 2012 with SP1. If you're on XenDesktop 5.6 and you want to go to Server 2012, it's not going to work. You need to go to version 7 for a variety of reasons. But if that's an architecture you're looking at from the latest and greatest in terms of the hypervisor, you need to be on version 7. What is new and specifically focusing with Hyper-V? If you're familiar with Hyper-V in the past, one of the things that was a big challenge in terms of scalability is the requirement of a legacy NIC and synthetic NIC for PXE boot. The reason why it was a challenge is because we had both NICs and we couldn't necessarily just use the synthetic NIC to boot PXE. We need the legacy NIC. It was a function or requirement of Hyper-V. Not of us, but of Hyper-V. Now, that's gotten a lot better in version 2012, but what's changed is the ability for us to switch over data traffic. So when the first machine boots, the first 20 meg of that operating system that loads will load and default in PXE. and we'll load in the legacy NIC. But immediately after that, it will switch over to synthetic. So all the enlightenment you get of the network drivers and so forth, it's automatically there, out the gate. And the cool thing is you don't have to do anything. There's no tweak, no registry change you have to apply. It's natively going to do it on its own. BDM. This is another awesome tool. This is new in version 7. It exists before in an ISO format. And what do I mean by that? One of the biggest things that we found that in enterprises when they're building this architecture is they find out that we have a problem with Pixie. We can't support it. There's firewall rules. There's VLAN issues. We need to find a way around Pixie broadcast. And what ISO or BDM ISO did was allow you to use an ISO model to each VM, boot via a Pixie-less broadcast, and then grab your provisioning server to stream your virtual disk. In version 7, we've actually injected BDM so that it's part of the provisioning server wizard. So when you want to spin up 100, 1,000 desktops, you have a choice. You can do BDM or you can do old school Pixie. So it's a choice, and it's enabled out the gate right within the provisioning server version 7 console. Some of the things you also see here, there's a lot of other cool things that we'll get into in the next slide, but PVD is also included as part of the wizard as well, if that's a feature you're looking at for personalization. Once you select that option, you'll see there, BDM is a choice you can pick. After the VM is created in Hyper-V, you can see there's a couple options that show up on the right-hand side. The first one is going to be the .vhd, which actually says _BDM.vhd. That is your 8 meg BDM boot file that will boot directly to the Hyper-V servers as opposed to having to do a Pixie broadcast. So think of it as booting from a disk without Pixie. That's effectively what you can do. So it's a really, really nice thing that's natively right within the UI. Multi-NIC support. If you have a design where you have a variety of NICs, multiple VLANs, you want to aggregate bandwidth. So you have more. You can use multiple NICs that's supported in Provisioning Services version 7. So you can actually segment your traffic if you still want to go down that route, or you can put multiple NICs together to increase bandwidth. Automatic creation of write disks. This is probably one of my favorite ones I absolutely like. One of the challenges we had specifically in Hyper-V is when you want to create a write cache, every time you make your master image, you have to store the write cache in the SCVMM library share. Just a requirement. We have to go to VMM, grab the template and say, hey, I want to spin up 1,000 desktops. Oh, by the way, I need this write cache VHD file, and it has to live within the library. Now, there's ways around that with PowerShell. I can bypass all that and just do stuff via PowerShell in individual increments, but that's kind of a challenge when you want to do that. So what's nice about this is that the write cache will actually be automatically created on the fly. So what does that mean in English? That means that when you go and provision 100 desktops, the write cache file does not have to exist in the VMM library. Matter of fact, your template from SCVMM doesn't even have to have a disk attached to it. They're completely diskless. It will create it automatically for you on the fly and go through the process of creating whatever, 100, 1,000 desktops. You pick and you choose which ones you want to do. You can see here at the very bottom, there is a sign that shows the write cache VHD file is added. So if you're doing BDM, it'll actually create the write cache for you as well. So 2 steps, now in 1. So it takes care of some of the pain of having to do this manually if you want to do a boot BDM ISO. It's automatically there for you. Write cache percent counter. Probably another awesome thing I love. When everyone's designing stuff, they're like, well, I don't know how much of my write cache I'm using. Is it 10%? Is it 5 gig? Is it 6 gig? Well, you really couldn't tell before. It wasn't possible. With this new tool that's built directly into the agent, when you actually log into a desktop that's in a shared vDisk mode, you actually can see exactly in real time what percentage of the write cache you're using. So if you provision 1,000 desktops and you say, well, I provision them each with 4 gig, and you really realize I don't really need that much space. I want to save storage. How do I do that? I can go and see in real time what my virtual disk status counter is like. Built right within the agent, you don't have to do anything. It's automatically there. SMB3 support. If you're looking to build and store your desktops on SMB3, we support it 100%. I just did a competitive test on another hypervisor per se, and I used SMB3 for 2,000 machines booting, and it was flawless. It works really, really well. And this is on server 2012, not R2, mind you. So SMB3 does work really well if you're going to store your virtual disk there and you're going to boot from them. Also works for storing your write cache if you want to go down that route. So let's go straight into a demo, and let's show you what that looks like in terms of some of the new UI interface. All right. Everyone see my console okay? Good. All right. So we're in the PVS version 7 console. The first thing I want to do is actually go through the XenDesktop setup wizard to show you some of the things that you can look at when you're doing this in version 7. So I'll connect to my XenDesktop controller address there. It's going to enumerate my resources that I have. So I'm going to pick host number 1 is where I want to provision my desktops to. Once I log in and enumerate the resources I have, it's going to spit out a series of templates from SCVMM. It's going to say, hey, you have access to this template, this template, this template, and this template, and this is a template I'm going to choose to mass produce my machines off of. Now, this template here is automatically set up with no disk. It's an empty shell file, for lack of better words. When I select that and go to next, everything else here looks the same. I can pick a particular virtual disk I already have shared. So this part is pretty similar. I'll select my catalog, click next, and you'll see there is the option where I have BDM. So I simply select that function when I go through this process, and instead of me having to worry about having my write cache file existing within my VMM template, I don't have to. I just pick BDM. I select how big I want the write cache to be, 6, 7, 8 gig. I select my dynamic memory settings, vCPUs, machines to create, and so forth. Click next, create a couple accounts. We'll throw that in this default machine here, and we'll click finish. This process takes about 1 to 2 minutes on my laptop, so it's not super fast. But what's interesting that you may not know is when it goes through this process, it's going to create that write cache and that BDM file in a dynamic VHDX format every single time. You can turn it off if you want to, but if you think about storage savings, that means that if I want to create a 6 gig write cache, yes, I should plan for 6 gig, but in reality, it's not going to be 6 gig out the gate. It's going to be really small. So we'll let this run. And then what I'll do is I'll go over to my 2012 box here. And we'll see I've got another machine that should be created right here, Win 7. If I take a look at this one, I've already provisioned. Let's see, that's one right there, that one. Oh, my IT department's trying to push stuff out. Let's kill that. So there's my BDM file. It's 8 meg in size, so it's nothing for me to use boot BDM to be able to get around Pixie. But my write cache size is dynamic VHDX. So it's going to grow as needed on demand. So that's a great thing because then you can figure out, well, I have this sort of storage subsystem, it's a Fusion IO card, it's DAS, it's whatever it may be, but I know I'm not going to have all these desktops running at the same time. You can kind of figure out how much you're going to use over time by just selecting dynamic VHDX format. Now, that does have an IOP penalty, so keep that in mind. These are going to be growing and shrinking on demand, so that will have an IOP penalty. But it's nice that you can actually do the creation in a much faster time, which we'll get into. All right, so let's flip back over to the presentation. Grab our pointer. So what are the stats? What does it look like when I want to provision 100, 500, or 1,000? Let's get into what I have set up. Now, this is a lab. A lot of this data I've done, and I've already presented twice at TechEd in various countries. So I will say that these stats will vary based upon your environment, so keep that in mind. Mileage may vary depending on your hardware, your storage, and so forth. This also was done before XenDesktop 7 RTM code. It's actually done on release candidate code because I had to have this data at the very first TechEd in North America. So I haven't done a new set of tests to revise this, but some of the other tests we've done with other vendors have all the RTM code bits. So they're not too much different in terms of scalability. So in this test, we use Windows 8 32 and x64. Primarily, we're doing 32 for most of these tests. It had 1.45 gig of RAM, and it was static, mind you, not a dynamic memory setting, and it had 1 vCPU. If I go through some of the charts here, you can see there's some interesting data versus Pixie versus BDM. A lot of people say, well, what's better? It's really not what's better. It's which one do you want to do. If you take a look at the orange chart, you can see when I provision either 100 or 1,000 via BDM, the creation process takes longer. Why does it take longer? I can go back and show you real quick. We'll go bounce over to this demo over here to number 5. I'll see if this one is done. So you see this one I just provisioned? This is the one I just did with PBS. You actually see it's also shutting down. Why is it shutting down? Because when I went through the wizard, I had to create the write cache on the fly. Remember, it doesn't exist in the library, so it's not like I can attach this VHD and it automatically is going to be there. When we do it this way with BDM, we have to create it, turn the VM on, add the VHDX file, shut it back down. So that's where this penalty comes in if you want to go down the route of using BDM. So if we go back to the slide, you can see here, the VDM creation process, whether using SMB or not, will take longer because the VMs have to do twice the work. Turn on, turn off, then it's ready to be used. So that's something to think about. If you want to go BDM, you have to be really careful about figuring out what's the time to create them, especially if you do 1,000. So let's say you have a Gen 8 blade right in front of you, and it's already 50% loaded, and you want to provision 100 desktops. What's going to happen? You're going to impact the people on that blade because you're saying, send all these commands to the Hyper-V box, build me a couple hundred VMs, and oh, by the way, I don't care what happens to the people that are on there. So you have to think about those things intelligently because it does require CPU resources, which we'll get into. The power on process is pretty interesting here, whether you're looking at Pixie or BDM. Now you can see in the 1,000 SMB space when we did this, I just really couldn't do any more stuff with BDM. Kind of ran out of time to do any more additional testing. But you can see if we're going with the Pixie route, it is a little bit slower in the process because it takes a little bit longer to boot versus BDM. Registration time is also interesting. If we look at whether we're doing 100 or 1,000, at 100 users, it takes us 5 minutes to do it via PVS, but it takes us about 6 minutes at BDM. So registration time also has a difference in when you build 100 or 1,000 VMs. So something to think about as you go through your design process, which is going to take longer for me to register. Power on, off, delete, same thing here. If you want to go through the slide, you can see power on and power off at about 100, not a big deal. Once you get to 500, then you're in an interesting game where you have to figure out how fast do I need to shut stuff down if I'm in a maintenance window, how long is it going to take? So these are interesting points you need to learn as you're going through the design process. If I'm using cluster share volume, this one specifically, I don't know if it had the additional functions of the cluster shared read-only cache function. I have to double check when we did this test, but not too much difference whether you're using PVS or whether you're using BDM for Pixie or BDM. So just a little bit of a difference in terms of seconds for that part. Power on, the same process, PVS, Pixie, whether you're doing 100, not too big of a deal. When you get to 500, it's about 2.5, 3 minutes. And registration, pretty similar. I mean, they're almost neck to neck when we're talking about registration with the controller. And the last one is power off, delete. So that's an interesting one. With PVS, with Pixie, it actually takes longer when you have to power them off or delete them from the controller than it does with BDM. So these are some tests you want to actually go through, apply in your world, see which one makes the best sense. So here's something else that I really like. This is one test that I did that I found really, really fascinating because there was a requirement, or actually more of a request from HP. They wanted us to do a new design that was different from what we ever have done before. And I said, okay, let's try it. We've never really done this design with them, so let's see what happens. We've done BL460 blades, but what we haven't done before are blades with Fusion I/O cards. So by show of hands, how many of you guys have Fusion I/O in your environment? Not many. It's kind of expensive, isn't it? It's expensive, but it's very good. A lot of times when I've done these tests, whether it's 100 or 2,000 or 5,000 desktops, the most common thing everyone is concerned about is IOPS. What's my bottleneck with IOPS? As we go through this test, you'll see that was not my worry at all, or IOPS, because of this sort of device. So that's something to keep in mind. There are other ways. There are other solid-state disks. There are DAS things I've done before. There are a variety of ways you can do it. But if you're curious on what's the fastest way, Fusion I/O is one of those functions. So here's what we had. We had a 460 blade, server 2012, fully loaded with 256 gig RAM. It was a beast. It was super fast. It was just about everything we could throw at it. The only thing that wasn't the absolute latest was a Xeon proxy, because we wanted to use something that was a little more common than what most people had in their environments. And we had a 1 terabyte Fusion I/O card in this server. I even did tests with 768 Fusion I/O cards, and I'll show you why that actually didn't work and why I needed 1 terabyte. So what do? We use LogMVSI. If you're not familiar with it, it's a workload generator that just about everybody uses. We use it, Microsoft uses it, VMware uses it. It's pretty much the industry standard tool for scale testing your infrastructure for VDI or whether you're using RDS. Doesn't matter. The workload that we chose was medium. The reason why is because it's the most IOP intense. And we thought, well, we have a card that can handle in excess of 200,000 theoretical IOPS. Let's slam it with the hardest workload that's possible from a workload generator standpoint. Went through all the same process. It opens up Office, does some printing, does some Adobe stuff, does some Excel stuff. It's a pretty boring thing to watch. If you've ever done this, I mean, I watch these things for 8 to 10 hours. It's really boring. So unfortunately, I don't have 2,000 friends I can say, go log in and do some tests for me, so I have to make them up in Active Directory. So this is how I do it with their tool. Here's the VM configuration. So as Windows 7 x64, it was 3 NICs because we wanted to do something completely different. A lot of people say, well, I've got all these different DMZs. I need 3 NICs on my particular virtual switch because one's connecting to a secure, non-secure, and so forth. So we tried with 3. And we also tried with 1 vCPU, which is pretty normal. The dynamic memory was 768 to 1536, which is pretty safe for Windows 7 at a medium workload. The bin file is the coolest thing. Having done this same test on Gen 8 blades 2 years ago and actually presented that here at TechEd and did the exact same presentation, the challenge with the bin file is always storage. And Server 2012 dramatically changed that. And I'll show you how it does it a little bit later. Here's what the results are looking like. It took me 53 minutes to create 225 desktops via the PVS setup wizard. Now, that was going down a variety of routes. I could have done BDM. I could have done a variety of different things. But I wanted to punish that Fusion I/O card. So what I did was the streamed wizard, which actually does not do a dynamic VHDX file. It does a fixed VHDX file because I wanted to throw more IOPS at it and punish it as much as I could. Or else, if I wasn't so concerned, I would have done the normal wizard, let it do the dynamic VHDX, let it do BDM. But I wanted to do the streamed wizard. The power on actions that we changed, because we were in a hurry, we wanted to really see if we could crush it, was 30 VMs a minute. So when the controller talks to the VM, he says, hey, you know, how many VMs do I have that I can start up now? We say, boom, fire off 30 every single time. Is that good? Not really. We pegged the Hyper-V box immediately. If you look at this chart, this is what happens. So don't do this in production, please. I'm begging you, because I'm not going to support you if you do it, and neither will Microsoft. This is an extreme use case, and we tried to see how is it going to react over time, whether it's beginning state, medium, steady state, and of course at the end as the test starts to finish. So 220 VMs at 30 actions per minute, peg the processor for 100% for 20 minutes. Not a good idea. What is a good idea? Same setup, 53 minutes, 225 desktops, 15 actions per minute, 23 minutes to register. You see that? At 15 actions per minute, it took me 20 minutes. At 30 actions, it took me 29. So what does that mean in English? If it ain't broke, don't fix it. What is set up by the default in the controller is 15 actions per minute. Now, you can get a little creative and go up to 20. But the higher you go, the higher penalty you're going to push on that host. So the performance was very acceptable. Take a look at the chart here. At 225 at 15 actions per minute, it did pretty well. That's a pretty acceptable CPU chart. It got pretty busy, but in the end, it was all right. Scalability results. So I also tried this with 240 VMs powered on, 240 fully registered when I went through my test for a few hours. The VSI max score I achieved was 233. So this is a chart that shows I had 233 specific VMs in terms of a max. So a max is meaning, hey, it's the point where it's acceptable, but user performance kind of started to tank. That doesn't mean you're going to get 233 VMs. It's a theoretical number. Subtract 20, 30, 40%, whatever you have. Add in antivirus software, subtract another 10, 15%, it all changes. So this is the most common medium workload, and this is what we could achieve with version 7 on a Gen 8 blade with a Fusion I/O card. During that whole process, during that test, you can see the logical CPU is 94% on the Hyper-V box. So it was super busy. It was doing its job like it's supposed to do, but it wasn't fully saturated. If I went down to maybe 220 desktops, it probably would have peaked at maybe like 80, 85 throughout the whole duration of the test. The available RAM at 256 was 6. That's how much RAM I had free during the whole entire testing phase. So is it something I'd recommend? If you're extreme, you're at max density, that's what you're after, you could attempt it. How did the I/O card handle from HP? So the I/O this theoretically can go 250,000 IOPS. Its peak during the whole time was just about 2,000 IOPS. That's it. So it just sat there and told me, like, is that all you got? It was literally just giving me the finger, like, come back with something faster next time. And as we went through these tests, we've done other tests that are much, much more aggressive. Mind you that this is VSI version 3.7. In version 4, there's a heck of a lot more I can do with manipulating, modifying IOPS, and getting more intense testing. So by default, their version 3.7 is not the most IOP intense testing tool, but it gives you an idea of how things would work in a similar workload. You can kind of see here, this is what the IOPS looked like during that whole entire time. The F drive was where my Fusion IO 1 terabyte card lived. And those are performance stats as I went through the whole thing. So a lot of stuff is interesting, but I've got some even cooler things. I'll show you some tips and tricks that I found that work really, really well in the sort of testing that I do daily. If you're looking at using Hyper-V, one of the most important things you need to be concerned about is calculating the storage for your bin file if you don't modify it. Why do I say that's important? I speak with countless customers and partners and say, hey, I built 1,000 desktops and I realized when I powered them all on, half of them didn't work. Okay, did you calculate the storage you need for your bin file? What's that? Okay, let's have a discussion. So that's when it gets interesting. This is a specific requirement for Hyper-V. What gets really cool about that is you don't have to do this in 2012. You don't have to. In 2000, R2 and its predecessors, it was a requirement for the bin file, but not in 2012. So when you're calculating and trying to figure out, well, if I leave the bin file on and I need this memory state saved, what is it going to take in order for me to use this properly on my storage system? So while it does increase IOPS because you have to create this memory state, there are ways that you can change it. So if you saw on that previous page, if I left the bin file on, I have to double my storage count and cost potentially. If I cut it in half, I save storage, I save cost. Pretty simple math. Simple economics I like to look at. So a 10 gig write cache for provisioning server, and if I turn off the state of the bin file at 0, that means the total storage I require is 100 versus 200 gig if I leave it on. How do you do it? That's simple. Here's a PowerShell script you can have. You run this PowerShell script on your SCVMM PowerShell console. You don't run it from the controller. You don't run it from a normal PowerShell window. It must be done from VMM. And the reason why it must be done is because we have to leverage the libraries from VMM to talk all the way to Hyper-V to make this work. So let's show you how this works. At the very bottom, there's a link. I highly recommend you visit this guy's site. One of the guys that helped me work on this script and some of the other stuff you're going to see coming up is a guy named Brian Ehlert. He's a VMM MVP, a Hyper-V MVP, and that's his website, IT Proctology, looking at IT from the inside out. You'll love it. It's a super nerdy site. You want PowerShell scripts galore on everything, that's the site you want to go to, and it's all free. He gives it all away. He's a genius. So let me show you what does that look like if I want to run this simple PowerShell file. We'll switch over to 5. And what I'm going to do is jump over now to my host. So here's one VM I've already created, right? If I go to the settings of it, and I look at my write cache file, not my write cache file, my memory state right here, you can see my start action is set to save. So what that means is that when I create this bin file, or when I power him up, that bin file is going to get automatically created equal to the size of RAM that I've assigned. So if I'm using dynamic memory, the biggest he's going to get is 1536. Shouldn't get much bigger than that. So how do I change that? Well, I have to have the machine off. That's step 1 before I run the PowerShell script. I bounce over to VMM, and I open up my VMM PowerShell console, and I run this change bin file here. He's going to say, enter the prefix you want to search on. Fair enough. I'll say TechEd Win7. It's going to go query VMM and say, OK, great. Do I see any machines that match this naming convention? If so, I'm going to run through my PowerShell script and automatically change the bin state to be off. So what does that mean when I turn him on? If I bounce back over to my host and I click Start, he'll start up. And if properly changed, his start action down here, oops, I might have done the wrong one. it says shut down. So it will change that to shutdown state, but the bin file actually should be 0. It's actually that one right there, TechEd. There we go. Shut down guest operating system. Does it automatically for you. You can run it on 100,000 VMs, doesn't matter. All you have to do is run it from the VMN console, and it'll change it automatically for you. So it'll cut your storage in half by just removing the bin file. The reason why we don't need it is, again, we're using PBS. I don't necessarily need that bin file because my disk is in read-only mode. It's not a hard requirement for us. Maybe for other VMs it may be, but not for PBS. Interesting stuff. So let's go back to the presentation. Another tool you can use, auto-write cache intervals. When you create your desktops using the provisioning services wizard, by default, it's going to create 10 at a time. It does this because it's intelligent. It doesn't want to overload your host and create 100 and just crash, and then you pretty much are SOL. If you feel froggy and you want to change this so you can do more than 10, you can do 20, 30, 50, 100. If your host can handle it, here's how you change it. You modify the reg setting, which is under the HQ current user variable for the person who's a PBS administrator. Make a couple change in the max VM create threads to 1 or up it, and then you'll be able to create as many as you feel you want to do in an interval. This is not something I'd recommend in production. Test it, see if it works for you. It's a very limited use case. Most people are okay with doing 10. But if you need to do 1,000 or you need to do something that's moderate, you can use this tool. Disabling this guy in Windows 8. Love it, don't love it in VDI. I don't need a high window. I need just to log in and get my Explorer shell. So if you want to change this in your master image, here's how you do it. You go to HKLM, modify this machine in private mode, append this, and next time users log in, you won't see this pop up. It's gone. It won't be there. Windows 7 themes, probably a really hidden trick that a lot of people forget about. This is something that I've seen with my own eyes that does make a difference. Arrow provides the best user experience. Every one of us that use Windows usually use something Arrow-like on their physical machine. But in VDI, it's a little bit different story. If I change Arrow to use a group policy, what does that mean in terms of scalability? It could potentially go up to 20% because Arrow requires CPU processing power. Take away Arrow, give it a little bit of a skinned down look and feel that's not so Arrow-esque or Arrow-like, my scalability now goes up. So if you're looking at max scalability, you want to push the envelope as far as you can, this is something you can apply in your test environment and see if it works. It's not so happy for the users. They're going to freak out and say, where the heck is my normal start button? But hey, we're after max scalability here. In version 7, we already have some high scalability policies in place, which is even better. You can just apply these to your desktop groups and automatically have some scalability increase if you want max scalability and not so concerned about user experience. There's a couple other ones that aren't here that are not in this policy that I can talk about later on. It's actually in the console. It actually will change from H.264 to legacy mode and actually adjust your protocol. So you actually will get about a 10 to 15% gain as well instead of using H.264. So here's what I was talking about earlier, advanced settings in the controller. The default is 10. I think 15 is okay. It's pretty safe. I wouldn't go above 15, but again, the choice is up to you. My testing says 15 is pretty much the sweet spot. So that brings to the end. Like I said, performance stuff is interesting. Some people like it, some people don't. But over all these years of doing it, all of us that have done testing over and over and over again, we kind of get to this point where like, wow, this sucks having to build everything manually. And there's unintended installs that exist, but what we're after is something that is really easy. We want to find a way to make the installation of XenDesktop and its components and its infrastructure simple. And that's a project that we took on internally at Citrix. So this is something I'll show you. It's a prototype. And it's not quite out. We're working on it still actively. There's a brand new build just released this morning. But I thought what I'd do is I'd show you a little bit of a video. The video is about 5 minutes long. I'm going to fast forward through some of it because it's kind of like watching paint dry. There's some parts that aren't so interesting. The end part is what's cool. So let me go and click play here. What this video is going to do is show you what's called a service template from SCVMM. While it's theoretically possible you could do something like this on another hypervisor, it is nowhere near as easy. I guarantee that. The way these service templates work from a cloud provider perspective or even private cloud is impressive. And what we're doing inside Citrix is leveraging these service templates to make our infrastructure automated from the ground up. So the first thing we're going to do is we're going to go ahead and go to our Hyper-V host. We're going to create a service. Now, I've already done the work. What you won't see here is actually importing the service template. What he's going to do is select that service template there called XenDesktop POC. He's going to give it a particular name that we're going to go through and append. And usually we're calling this a proof of concept because we're still building it. It's not necessarily prime time, ready for 100,000 users. So the service template then brings out the design so you can see what this looks like. I'm going to stop it right here so you can see. What you'll see right there is the credentials we're putting in inside the service template. I'm putting in my domain name, my password, a bunch of information that's specific to me, the architect, the administrator that's building out my virtual desktop infrastructure. Now, I could be doing this and still building Windows 8, Windows 2012, Windows R2, doesn't matter. But until we can get that point, we have to have the underlying components, which is XenDesktop. So it's going to go through, we'll put in the rest of the information, username, he appends his password, domain. Here's where it gets really cool. After we put in our password, we're going to put in our credentials for the farm, for XenDesktop, automatically. We're going to put this information into the service template. We're also going to put in our password. We're going to give the delivery controller a particular name. All the things you would do if you haven't installed XenDesktop 7 manually, these are things you'd have to do. We're just putting it into a service template for you so that when you do it, you import the service template. You don't have to go and create your individual VM, install it, install a .NET framework, go through all that stuff. We're going to do it all for you automatically. So when we create the service template, we're going to go ahead and then deploy the service. At this point, he's going to go ahead, talk to VMM, go through the process of creating the service template. So what you'll see here is we'll expand that, and you'll see a series of things occurring within the VMM jobs window. And I'll kind of fast forward through this a little bit if I can. Oops, let's go back. Yeah, I can't quite see how to fast forward up here, so give me a second if I can do this. Yeah, presenter mode is fun trying to figure out how to fast forward stuff. Give me just a sec. We will bounce out of presenter mode real quick, and then we'll hit escape. And I'm just going to show this in a smaller window here. You guys still see it okay? No, all right. We have to get out of presenter mode. Hold on a second. Okay, now you see it all right? All right, well, I can't see it, but I'm glad you can. So I will fast forward this a little bit. Now, you'll see the jobs window appear. All these jobs are executed. So what does that mean? That means we took an ISO, we took a sysprep VM, we built it from the ground up. We built our controller, we built our storefront server. We're also working on building PVS. So each one of those individual VMs, we built for you from the ground up. You didn't have to build anything. It was all done. All you needed was an ISO and a sysprep VHD file in the VMM library, and it's all done for you. Apply a little bit of credentials, and when you see here, we'll log into these machines. Now, it's not just like we're installing it for you. Remember, we created some variables. We called it a farm name. That stuff is appended automatically now to the XenDesktop Studio when we log in. So I will fast forward this a little bit here so you can see. So there's our Studio console. When I launch it and open it, it's going to go ahead and appear that it's fully configured. So all of that is stuff that we're working on. Same thing applies for Storefront. Create Storefront, install Storefront, configure it. And we're also working on PVS as well. So all those major parts, you can't build a VDI infrastructure for XenDesktop without these parts. We're automating for you on the fly. Pretty cool? I don't think there's anyone that doesn't like automation. I'd rather go and watch a rugby game and let this stuff do it by itself than having to click next, 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 next all day long. Right, so let's try to bring this back over here if I can. And we'll go back into full screen. All right, let me know if you can see the PowerPoint. Good, all right. So let's go to our next slide then. So that's one thing. There's more to come. Each of our vendors that we're working with, our particular hardware partners, we're building individual reference architectures for version 7. Cisco UCS platform, Dell platform, IBM platform, and of course HP. So if you have a particular hardware platform you like that you're married to, not a problem. Each of these are called validated designs. What does that mean? That means that we're going to test this from the ground up. When we build a design with our partners, we test the hardware, the software, everything as much as we can, and then we deliver that in a blueprint format publicly to the web. So we have a couple that'll be out really, really shortly. Probably, I think Dell and Cisco will be the first ones, if I'm correct, and then HP will probably be right after them. So that almost brings us to the end. I know you guys really only came here to get this, right? That's what you want. You want the solid-state drive, so I'm going to give it to you right away. So we're going to pick, or I'm going to pick one person. I'm going to keep it real simple this time. But I got 2 things to give away, so I'm just going to throw these, right? If I hit you in the eye, I apologize in advance, but I'm going to throw them. First person to catch it. One there. One over there. Oops, my bad. Which means I'm going to pick somebody from the middle to come up, right? But I need audience help. If you were in my session yesterday, had a really fun game, but we're going to do something different. But it's still going to be fun. I'll pick the guy in the green, black striped shirt. Yep, you. I'm going to pick you. You come on up. All right, so I'm going to need your help. And here's how this game is going to work. It's really simple. It's not complicated. You're going to like it. You can ask the audience for help for an answer, kind of like Who Wants to Be a Millionaire. All right? Couple easy questions. I'm sure you're going to get them all right because you have all these people to help you, and you're going to get a solid-state drive. Pretty simple. Are you ready? So we're going to play Mythbusters. Your choices are going to be confirmed or busted. That's it. There's no plausible here. It's confirmed or busted. Those are only 2 answers you have to the questions. Get them all right, you get a solid-state drive. Sweet? Sweet ass? Or sweet ass? Excuse me. Got that backwards. Let's edit that afterwards. Question 1. Citrix was not always called Citrix. Is that confirmed or busted? Confirmed. That is correct. In the very early 80s, late 80s, we were called the Citrus. True statement. Confirmed. Next question. Citrix can't deliver virtual apps and desktops from one console. Confirmed or busted? Busted. That is true. Version XenDesktop 7, we do XenApp and XenDesktop in one UI. Third question. XenDesktop 7 takes 30 minutes to install and configure. Think about what you just saw. Crowd? Phone a friend? Phone a friend? Yeah. Do you think that is busted, that it does, or confirmed that it, busted that it doesn't, or confirmed that it does take 30 minutes? Busted, right? It took me 15 minutes to do all of that stuff from the VMM template. That easy button took 15 minutes to create everything. Build the VM, install the controller, build the VM, install Storefront, 15 minutes. I even timed it because I looked at the logs and the VMM jobs, exactly 15 minutes. And I don't have a super high-end server. That's just using automation. It's pretty cool. That's a big time saver. It means more time to watch rugby, right? Last question. I need a hypervisor to have a HDI with XenDesktop 7. HDI, not VDI. Confirmed or busted? Never heard of it. Never heard of it. What do you think it is? Take a guess. It is busted. Remote PC is the fastest way to do XenDesktop without a hypervisor, period. But the agent on a machine, you don't need a hypervisor. You, my friend, are a winner. Cheers. Congratulations. Questions and answers. I've got time. If you guys have direct questions, if you want to shout them out, I'll answer them. If you want to have some chats afterwards, you just have some architecture stuff, you're concerned about scalability, I'm available. In terms of features, one of the things I always get questions asked about is, I got to give something to my C-level execs. They keep asking me, why do we spend money with Citrix? Here you go. Each of these are interesting features that when you talk to executives and they want to know the bullet points, the key things as to what we provide that make us so unique, you give them this chart. And you say, I'm pretty sure we have scenarios that fall into most of these categories. All right? So it's a nice little eye reference chart for you to use. And last thing, related content. So I did a session yesterday, a lot of great demos, a lot of individual things. If you want to see big scale, 100,000 plus machines, you want to watch the session from last week in Australia from the Australian Department of Defense. The architecture's there, the whole Visio diagrams are there, everything about how they build XenApp and XenDesktop with PBS, how they do it, it's there. They won't go into the exact details, but they'll give you the architecture overview. I highly recommend you guys watch that session. It's well worth every minute. And then please fill out your evaluations. Any questions? Nope. Oh, you got one question. Okay, go ahead.
Consider moving from MCS to streaming services? Is there a rule of thumb around how many?
The question is, would I consider moving from MCS to...
Would you consider? Because MCS is so easy, of course.
It's very easy. There's absolutely no question. It's very, very easy. Would I consider it? If I want to use some of these features with PBS and I want to integrate with System Center Configuration Manager, yeah. There's a lot of great things that MCS doesn't do that PBS does. So like you saw, eliminating the Pixie thing, that's a big thing. We never had that before. That's a feature of version 7. All right, well, thank you guys for attending.